Hi, my name is Josh, and in this video I'll be demoing my entry for the Microsoft Sentinel Hackathon for Spring 2022. The Rumble Network Discovery solution from Microsoft Sentinel is a network domain solution that enables organizations to enrich their hunting queries with the daily export of asset information, as well as receive alerts when new assets are discovered on the network or high-value assets are modified. As you can see, the solution consists of several components. First, there's an Azure Functions data connector with two PowerShell functions. One with a timer trigger to receive asset information from the Rumble API, and one with a HTTP trigger to receive alerts via a webhook when new or changed assets are discovered on the network. The Azure Function app also integrates with Key Vault to securely store and retrieve secrets such as the Rumble API key. Once the data has been retrieved from Rumble, it is sent to Microsoft Sentinel via the Log Analytics Data Collector API, where parsers are used to filter and manipulate the raw data received from Rumble so that it's usable. This data is then used by a workbook to monitor and provide insights into the environment, hunting queries to investigate the data in more depth, such as determining remote services that might be abused by an attacker for lateral movement, and lastly, analytics rules, which are configured to fire incidents when new assets are discovered on the network or high-value assets have been modified. Jumping over to Microsoft Sentinel, here's an example of the workbook that's included with the solution. As you can see, I'm presented with some interesting insights about my environment, such as the most seen asset types or operating systems, but also the prevalence of certain TCP and UDP ports, protocols, and services. Another key benefit of the workbook is the asset summary table, which allows me to query information about the assets in my environment without having to construct complex KQL queries. For example, simply by searching the keyword SSH in the table, I can easily identify all of the assets in my environment that have SSH exposed to the network. In my case, they're all Ubiquiti routers or switches, which is expected, but if I saw something unexpected, like a server, I'd now have a lead to begin threat hunting. Jumping over to the hunting queries page, we can see the example queries that are included with the solution. One to list all assets that have web interfaces exposed to the network, one to summarize the list of assets by TCP or UDP ports they have exposed, and one to list all Windows assets discovered by Rumble that are not forwarding security event logs to Microsoft Sentinel. These queries have also been mapped to some relevant MITRE tactics and techniques for your reference. Let's see what they look like in practice. Running the first query, we can see how easy it is to generate insights from our asset information. By simply filtering the service protocols field for HTTP, we can quickly get a list of devices that may have a web interface exposed to the network. Looking at these results, I can see that the management interfaces for several networking devices are exposed to the network, which could be abused by an attacker for lateral movement. I can easily review these devices and make a judgment call as to whether or not these interfaces should be segmented to another network. Moving on to the next query, we use the summarize operator to list all of the assets in our environment by their exposed TCP ports. This makes it incredibly easy for me to identify any assets with services running on uncommon ports, which may be indicative of command and control activity. Lastly, another benefit of ingesting asset information into Microsoft Sentinel is the ability to correlate that information with other tables. For example, I may have an organizational requirement to ensure that all Windows devices are configured to send security event logs to Microsoft Sentinel. Using the solution, I can easily compare the list of Windows devices discovered by Rumble with a list of distinct computers from the heartbeat table. In my case, I can see 3 Windows laptops that don't have the Log Analytics agent installed, which is resulting in a lack of visibility into these devices. I can now go and remediate the devices to stay compliant with my requirements. Moving on, the solution also includes a watch list, which is simply a CSV file containing a list of high-value assets that should be monitored for unauthorized network changes. You'll want to update this watch list with your own IP addresses, host names, or Rumble asset IDs so they can be referenced in your own queries and analytics rules. Finally, jumping over to the incidents page, we can see an example of 2 incidents that have occurred in my environment as a result of these analytics rules. One because a new asset was discovered on the network, and one because a high-value asset defined in the watch list was changed in some manner at the network level, such as a new service being exposed. Relevant details for the alert, such as host names and IP addresses, are mapped to their respective entities, so it's easy for analysts to drill down into the event. One thing to keep in mind with these alerts is that they may be particularly noisy depending on the size of your network, so you may wish to tune these alerts to, for example, only fire when a new Linux device is connected to the network rather than any asset. That just about wraps up my demo of the Rumble Network Discovery solution for Microsoft Sentinel. Thanks for watching.